Welcome back! In the previous video, we have explored how to create a very basic map using the basic Perlin noise function. Now, instead of using one Perlin noise, we could use multiple Perlin noise values and use something called octaves to generate a bit better looking Perlin noise. Again, I will point you to the Understanding Perlin Noise article that I have linked in the description of this video, and if we slide a bit, we will find working with octaves. So basically, what we can do is we can generate a noise with a high amplitude and low frequency and add to it a noise with a bit lower amplitude and higher frequency, which is a bit more flat. As you can see, if the frequency is a bit higher, then we are zooming out of the noise values and we can get a bit more hills, but they are of a lower amplitude, so they should generate us a bit more details into our noise value. So at the same time, we are going to generate multiple noise values with different parameters, and upon adding all of those, we can generate something like this that you can see at the end. It surely looks a bit better than what we have started with only one Perlin noise values. And basically the octaves mean that we are modifying the parameters, so we are dividing by half the amplitude and multiplying by 2 the frequency to achieve this effect. Again, if you want to learn more, I advise you to check out this article. Let's go back to Unity and let's see how it would work. Okay, now before we start modifying our world generator script, I will want to create a helper class that will store the parameters for our noise data. So let's create a new script and let's call it NoiseDataSO. Since this will be a scriptable object, let's open it up in Visual Studio. Okay, I do not want it to be a mono-behavior, I want it to be scriptable object. And I will want to create at the top of this an attribute create asset menu. So this create asset menu will allow us to create this from the level of the editor by right-clicking and selecting create, and we will be able to select data and noise settings. Now for the noise settings, I have prepared some data. So we will have a start frequency, which for us it will be 0.1, and we have it in range, so we can set it using a slider. Now the octaves are the octaves that we will use, and this will be minimum 1 octave, and we have the 3 as the default value. It will be an integer. Now we have persistence. The persistence is the value by which we multiply the amplitude. So to have the amplitude, we are going to multiply it by the persistence equal to 0.5f. So this will be a float value with minimum value 0. And we have the frequency modifier. So this will be the modifier that we use to multiply the frequency by. So we are going to set it to 1.2f, and this will be again a float value with minimum value of 0. And to have some sort of a seed, so to generate a different world, we can provide an offset on x-axis. So if we set it to some higher number, we are going to generate our noise in a different position. Now, of course, we could add something on y-axis and generate it on a different y-axis as well. It would add to the randomness, but for now, let's focus on x-axis. And we will have a noise range min and noise range max, because now, if we use our noise value in this fashion, we cannot really use amplitude to raise our noise value to the certain height of our height map. So we will need to modify the value and remap it from range 0 to 1 to some other range. So this will be 0 to 20, where 20 will be our height of the terrain. Okay, let's save it. Let's go back to Unity. Great. I will create a new folder and I will call it _data. And as you have probably seen already, we can right-click, create, and we have the data, noise settings, and those will be the ground noise settings. Okay, and as you can see, we have all the settings here in the scriptable object, which makes it much easier for us to modify those values, since when we are playing the game, those values will stay the same as we have modified it, and when we change the values in the inspector during the play mode, those values will be reset to the values before we have started playing. We want now to go to our underscore scripts folder and reopen our world generator. Okay, so I will want to have a new variable called NoiseDataSO, and I will have them height map noise data, which will be the ground noise data, the stone noise data, which will be used to create stone tiles as well as the ground tiles, so the dirt, and we are going to have the Perlin 2D data that we will use in the next video. Now, I will want to have the new method that takes into account the octaves that we want to use to generate our noise. So I'm going to slide it down and I will paste the method that we will want to use. This is sum noise, and this will sum the noise of multiple octaves. I'm providing X, Y, and the NoiseDataSO so that I have everything ready to generate our noise. Now, at the beginning, we need to set the amplitude, and again, as I have said, we will want to return a value from this between 0 and 1. So the amplitude, if it is set to 1 or 10, it will not matter because we are going to again remap it to 0 to 1 range. So that's why amplitude is 1. The frequency will be the frequency set in the noise settings.start frequency. This is the frequency that we have modified when we have generated the basic noise value. And we need to have something like some noise. So this is the value of the noise, and we add each noise value for each octaves. We loop through each octaves in this for loop. Now, beside the noise sum, we need to create a sum of amplitude values, since again, we want to map the value to be in range of 0 to 1. So we will divide the result, the noise sum result by the amplitude sum to achieve this normalized value between 0 and 1. So in the for loop, we are looping through each octave, and starting from 0, we are calling noise sum plus equals our amplitude value times math.perlin noise x times frequency. Next, after we calculate this, we are increasing the sum of amplitudes by the amplitude, and we are multiplying the amplitude by the noise.persistent, and we are multiplying the frequency by the noise.frequency modifier, and this is our new method to generate the noise value. Now, the issue of this is that we have it in range 0 to 1. So this is not good because our values on y-axis needs to be a bit higher, and we want to set it as the map height. And that's why we have set this noise range mean and max in our NoiseDataSO. So now we will need to have another function that will actually remap this 0, 1 to the range of our noise that we want to generate. So for this, we need a very simple method, range map, and we are going to map the input value that is in range in min, in max, so those will be 0 and 1, to the range out min and out max, and those will be the ranges, the noise range min and noise range max. So having those two methods created, we can slide up and copy the method to generate map, and we are going to paste it below, but we are going to change the name to generate map better. Okay. Again, we want to clear the tile map ground, and we want to loop for each x equals 0 to x less than map length. Actually, we can loop from -1 times map length to map length, so we have a bit bigger map. And now, instead of calling the get noise value, we are going to call the sum noise height map noise data dot offset dot x. So this is our offset, so our seed plus x, and we can pass 1 as the y value since we are working in a 2D environment, so we do not need a Perlin noise 2D, we only need a Perlin noise in 1 dimension. And we need to pass the height map noise data to generate correctly our noise. Now again, our noise is now in range 0 and 1, so we are going to call var noise in range equals range map, and we are going to pass our noise value. The in min is 0, in max is 1, so those are the range, this is the range of our noise, and we want to set the range of the output value to be height map noise data dot min, so noise range min, and height map noise data dot noise range max. and this will simply map our values. All we need to do is pass to our y coordinate the new noise in range value, and now we should be generating a bit better looking map. So now let's go back to, let's save the script and let's go back to Unity. Okay, I'm going to select our world, and I'm going to make sure that our height map noise data is assigned as the ground noise settings. And now we should be able to also assign to our canvas, to our generate better, and we are going to assign our world, and we are going to assign world generator, and we have the generate map better method. So this is the button on the bottom of the screen. Let's press play, and let's try pressing the button. And as you can see, the map looks a bit different. There are flat planes as well as hills. So we have achieved a bit different output. Let's select our data and let's change the values. I'm going to change the start frequency to be 0.08. I'm going to change the octaves to be 1, the persistent 0.5, the frequency modifier will stay 1.2, and I'm going to change the range max to be 30, and let's try generating it. Map generate, and as you can see, this is a bit different. Now if we increase the octaves to be 2, we should have a more detailed landscape. Let's set it to be 3, and as you can see, it gets a bit lower, but there are more edges and the landscape should be more detailed basically. Now this is great, and if we stop it, the values here are saved, so this is great. So now what we want to do is also paint our rock tiles instead of having only dirt. So let's select our data for the ground noise, let's duplicate it, and let's rename it to be stone noise settings. Okay, and let's change those values. I have experimented with something like start frequency 0.01, the octaves to be 1, and the height, I will want to have this lower to be about 20. Okay, and maybe change the offset to be 1500. Great. So again, let's go to our scripts and let's select our world generator to add our stone tiles as well. Okay, we are back in the world generator. I will slide down because we will need to have a new method, and this will be responsible for setting the concrete tile base, so tile that we want to set in the position that we have generated. Since we do not have imported the tile maps, so right click, quick actions, and say using Unity engine.tilemaps, and this will return a tile base, which is basically the tile that we want to place. And here we are going to pass the y value, the noise value, and the stone height. So the stone height is the height above which we should place only stone tiles to have the hills covered in stone, not in dirt. So we have only a simple if-else statement. If the y value is greater or equal to stone height, if the y is equal to noise value, so this is the edge of our landscape, we want to set the block data dot stone grass, so we want to place the grass tile, not only the stone tile. Else we want to return the stone tile. Else, if the y equals noise value, we want to set the tile to be dirt grass, not the simple dirt. And else we want to set the tile to be dirt. Okay, so this is what this method does. It selects the concrete tile that we want to set based on the values that we provided. Now we want to slide up to our method generate map better, and beside generating the noise for our height map, we want to duplicate it basically, and we want to name the noise stone in range, and we want to have the noise stone int. So those are the values of the stone that we want to generate, and we want to sum the noise and not use the height map noise data but the stone data. So we type stone noise data, and again at the end of it we want to pass the stone noise data as well instead of the height map noise data. In the range, we want to again pass the stone noise data to have the correct range mapped as our noise stone in range. And at the end, we are simply flooring it to be an integer value. So now, instead of setting the tile to be dirt, we want to call our select tile, and we want to pass here our y value. We want to pass the y coordinate, and we want to pass the stone or noise stone int. So maybe let's rename the y coordinate, so Ctrl RR, let's call it noise end value. So this is the value that we have generated for the height map, and the noise stone int will be the noise value for the stone. So now we are basically generating two Perlin noises, one for stone and one for the height map, and depending on the noise value of the stone, we are going to place the tiles of type stone above the certain threshold. So we have a diverse tile map in our game. And I have made a mistake because I'm passing here the noise in range and noise in the range map. So I'm going to change it. So to calculate the noise stone in range, we need to pass the noise stone. And to calculate the floor to int, we need to pass the noise stone in range. Now it will be correct. So again, we are going to pass the noise stone int, and the select tile will select what types of tile we should place. Let's go back to Unity and see how it works. Okay. Again, let's check the world and set the stone noise data to be the stone noise settings. And since our height map have been changed because we have duplicated the ground noise setting, but I have changed the basic one, I need to change it to be noise settings 1. Okay, so now if it is correctly set, let's press play and let's see. When we click map generate, you can see that it has generated to us a bit of stone or a lot of stone, and of course we can change it by changing the data, and maybe even let's change the map length to be something like 100. Let's generate our map. Okay, and now what we can do is we can modify our settings for our stone as we see fit. So maybe we want to place it only between 10 and 20. Let's try generating our map now, and as you can see, it has a much lower chance of stone here, and we can change the seed. So let's set it to be 2000. Let's generate our map, and it will be changing a bit, but basically that's how it works. Now this is great, but I would like to also have some sort of caves in our map. So to implement caves, in the next video we are going to explore how we can use Perlin Noise 2D to generate caves and overhangs. Great! So see you in the next video.